right?
Yeah.
It is. And we're going to look at the toughest shape today. So I want to, instead of leaving it to the end of the unit, this gives you more time to practice, to ask me questions, come in lunch if you don't get it. And once you get it, it's not so bad. Okay, and I'll try and go slow. If I'm going too fast, you need to tell me to slow down. Okay, promise? Okay. Okay, what unit is area measured in? Squared. Squared units. And what type of units is volume measured in? Cubed. Okay, so if you have a triangle, what's the formula for a triangle? Does anyone remember? Triangle, circle, yeah. Triangle. Becca? Base times height divided by 2. So there's two ways to write it. So if this is my triangle, here's my height, here's my base. You could either write it as base times height divided by 2, or 1/2 base times height. 1/2 times base times height. It's the same thing, right? Multiplying by half is the same as dividing by 2. Same thing. Now, on your formula sheet, guess what? You think these are there? You forget them? Yeah? Yeah. Hayden, can you see it that far back? You're welcome to move forward. You good? Okay. So on your formula sheet, the very front side of the formula sheet where you had Pythagorean theorem, at the very bottom there's all these linear formulas. Okay, rectangle. What's the air? Instead of base times height, we actually use legs, but it's really the same thing. That's supposed to be a rectangle. Forgive me. So area is length times width. And a circle with radius r. Brady? Pi r squared.
And you can also use circumference divided by 2 times the radius.
Circumference divided by 2 equals what?
Circumference divided by 2 times the radius.
Circumference divided by 2 times the radius?
Yep. Try it, it works.
Okay. 2 pi r. So circumference is 2 pi r divided by 2 times r, which would give you pi r squared. Yep. Very good. I've never used that one before. Okay, so moving on, let's look at our pyramid. So we're going to look at two types of pyramids today. We're going to look at a square and a rectangle pyramid. Who do you think is going to be more intense? Yeah, the rectangle for sure. But let's look at this. We're just going to name the shapes in front of us. So do you know anything here? Yeah? Yeah? The wall? Where's the wall? Oh, this? What would this be called? The right. Okay. So this is the altitude, the height. Let's fill that one in. You're right. That is the height. Now we're only dealing with right pyramids. So what do you think a right pyramid is? If you draw a line down the middle, it touches the center. So we're not dealing with slanted pyramids. Okay, so the center is directly, this actually has a name, the very top of it. Apex. Apex is directly over the center. That's the type of pyramid we're dealing with. Now this wall, we actually have another name for it. When you open them up, what do we call all the sides? Another name for the sides, yeah? A face. And what type of face is this? What shape? The triangular face. Funny name, it's a face. You can draw a smiley face, I guess. And then on the bottom, we have the base. Yeah, that's the base. So the base is either going to be a rectangle or a square. Yeah. Okay, so I should also tell you about a tetrahedron. Okay, you need to know the name of this shape. So what does a tetrahedron look like to you? A kite? Someone said something. Yeah? A triangular base pyramid. So really, it's made up of how many triangles? 4 triangular faces. Yeah, and they're usually all the same size. They will be the same size. The one, because it's regular. Regular means all the same.
those things that are in the Magic 8 balls, shake them around.
Oh, yeah, totally. So, know that what a tetrahedron, can everyone grab their formula sheets? See the blue at the back, Wyatt? Just grab one. That's your formula sheet. And I'm going to open mine up. Oh, of course, I closed. Okay, formula sheet. Okay, so on your formula sheet, see there on the front is all the perimeter and circumference and area formulas for the one-dimensional shapes. I guess they'd be two-dimensional shapes, actually. And our three-dimensional shape. So where is the tetrahedron? Do you see it? Yeah, you might want to actually, on your formula sheet, write underneath, maybe right underneath it, this is a tetrahedron. It's a very, tetra means four. They have four of the same faces. Tetrahedron. So this S, does anyone want to take a guess what this S means? Slant height. Yeah, this S is the slant height. So S is the slant height. And what's X? What are they labeling as X? Yeah, the length of this base here. Okay, so X is the length of the base. So why do you think the formula is 4 times a half SX? Okay, so 4 different faces. Yeah, and each face is what? Yeah, Anthony?
You can do S times X, and that would give you the width and the height, which would give you the square size, and then divided by 2.
Divided by 2. Remember we talked about dividing by 2, same as multiplying by half. So this formula right here is the formula for the area of a triangle. Right, we're really doing a base is X times our height of S divided by 2. So this is the formula for the triangle. And then there's 4 of them. There are 4 identical ones. So if we find the area of one of the triangles, we times it by 4. We have the surface area of the shape. Does that make sense now? Yeah? Okay? We're okay? So we're dealing with surface area today. Okay, let's go back to this. We have a right square pyramid. Okay? Now, and then we're going to also deal with the rectangular, which is not drawn here. And we won't deal with the pentagonal, but you can see the slant heights are drawn here. All right? Okay, let's go to the next page. We're going to draw some pictures. Okay, so how do you think you'd find the area of a pyramid? Okay, so with a pyramid, the side faces are always what shape? Triangles, and then we always have a base. So the sum of the areas.
You could also go to Egypt with a really, really large stick.
Yeah, good luck with that. It'd be easier to use trigonometry to do that. Okay, the sum of the areas of the triangular faces and the base. That symbol and the base. Okay. So sometimes if we have a rectangular pyramid, then we're going to have 2 pairs of same triangles or congruent triangles, 2 pairs. If you have a square, then they're all 4 are the same. Lateral area means the area of everything but the base. Okay, so if I wanted to find the lateral area of a pyramid, it would only be the triangular faces. So everything but the base. The area of all faces, excluding the base. That's something you might want to put on your study sheet. It's a definition, and if I ask you to find the lateral area, you'll need to know what that means. Okay? All right. This is where you get to do some art. You have your formula sheet to help you, so you might want to have that in front of you while you're drawing your shapes. Okay, so we're going to draw some of these shapes. We're going to start with the cone, which is right there. Right, you know this is a cone. Okay, so sketch of our cone. Make it a little bigger, actually. A dotted line for our circle. So we have our radius. We have our height. This is a right angle there. Okay, so if I wanted to find the area, and then we're going to just draw a little S here for slant height. Okay, so the slant height would be from here to here. So say you know H and R, how could you find S? Yeah, Bria? Pythagorean theorem, right? S squared is equal to H squared plus R squared. So if they give you the vertical height and the radius, but you need slant height, that's how you're going to find it. You're going to use Pythagorean theorem. Okay, that's a right triangle. Do you see the right triangle in there? Okay, so what's the formula on your formula sheet for surface area of a cone? Yeah, Nadia? Pi r s, pi r squared. Okay, we need to break down, and so you need to understand what's what. What happens is if we open up this, you have a circle, right? And then you have something like, actually it's more like this. I'm just going to draw it like this, okay? Something general shape like this when we open it up, okay? That's the net drawing. So the pi r squared, where do you think the pi r squared is from? The circle. And what do you think the pi r s is from? That triangle. This is the circumference here. So this is the circumference of our circle, which is 2 pi r. And we have our slant height here. What happens is we use the formula for a triangle. Triangle is 1/2 times the base times the height. 2 pi r, not 2 pi r s. Sorry, guys. Circumference is 2 pi r. This is s. So 2 pi r and then times our height of s. What happens is that 2 half times 2 is just gone, and that's how we get the pi r s. Okay, so this circle is their circumference 2 pi r, height of s, and it's a triangle. And so that's how this happens. Pi r s. Yeah? It's the s. It's the slant height. When you open it up, that's the height of the triangle. It wouldn't be h. Because you have to remember, I'll show you. Sorry. Wait. Let's not waste time here. All right, so moving on. Cylinder, this one should be easy. Right, this is our can of soup. Let's push record. Oh, am I recording? Good. Sure. But beans, the magical fruit. Okay, so we have our height. We have our radius. Okay, so when this opens up, what does the net look like? You've done this before, right? Rectangle and 2 circles. This here, what would be the length of our rectangle? What is it the same as? The circumference of our circle, 2 pi r. And then here's the height. And then each circle is pi r squared. So that's where we get our formula. Surface area equals 2 pi r squared, because of the 2 circles, plus our rectangle here, length times width, 2 pi r times h. So if I wanted lateral area, everything but the base, how would this formula change? I wanted lateral area. You'd only have 1 circle, so you'd only need 1 pi r squared. Yeah, so you could just change your formula to be 1 pi r squared plus 2 pi r h. Like the area of a garbage can. Yeah. Don't need the top in that case, right? Okay, right prism. This is boring. We'll draw it fast. I'm not exceptionally talented at drawing. You'll learn that very fast. It's not bad. Some of you are like doing the shading and everything too. Oh, wow. You are also kind. Okay, so surface area. How do we find the surface area of this shape? Do you remember? It's on your formula sheet, I believe, right? So length times width. How many length times width will we have? Times 2, right? Ooh, see, I just ruined it. Okay, the base and the top are identical. So there's 2 length times width plus 2, what else? Length times height, so we'll do the front and back face, plus 2 width times height. Okay, you've covered that. It was wonderful back in the day when things were simple. But now we come along and we make the pyramid. Okay.
There aren't any traits behind there where the back corner is like actually way out behind it.
No. It's just that. Okay, we're going to draw a square and then we're going to draw a pyramid. Okay? So I'm going to start with this right square pyramid. And then we'll draw the right rectangular pyramid underneath. There is still some room, hey? Yeah, you're good. Okay, let's talk about the square. So you might want to look at the back of your formula sheet or on the next page to draw it. It's really nice on the next page. Maybe that's the one I'll look at. Okay, so I'll draw a triangular face. Actually, I think I can cheat.
Hey, don't cheat.
Oh, no? I'm pretty sure I might have a shape somewhere. Okay, I'll try and draw it. Oh, that's a circle. I don't want to draw a circle. Undo, undo. Okay. Let's try this again. Cheating is bad, but... Okay, so there's the triangular front face, sort of. And then the side. It's supposed to be a square. Does that look kind of... See, they're so hard. Yeah, you draw the square first. Yeah, I usually do that. I'm going to try one more time. Usually I draw the square first. I tried to copy the other page. So on the base, we have the square base. You're going to draw it at an angle, kind of like a pyramid. Or, sorry, diamond. Not a pyramid. And then draw your vertical ones up. It's okay. There's really no winning here. Okay, we want to do a good job. The reason why is we need to draw our vertical height to the center, which makes a right angle. H. Okay. And you need to draw a slant height here, S. Okay, so if we had the net, and let's call the base, what is your formula? Let's call it L or B. Oh, no, what's your formula sheet? I think they use length and width. So we'll just use length maybe, or width. Let's use base. B. No? Okay. Okay, so if we were to draw this net, okay, here's our square base, B, all around, and then we have all the triangular faces. What would be the height of my triangle? Which letter would be the height of the triangular face? Yeah?
Is the pyramid as tall as it is wide?
Not necessarily.
Not necessarily.
Nope. It might just look that way today. It would be S. Thank you. Or Zach, you got. Yeah, you can say that too. Let's use this color. So your height would be S. The slant height. So if they gave you, say, your base and your vertical height, how could you get your slant height? What do you see inside here? right triangle. In fact, let's draw this to the side over here. Here's our height. Here's S. What would be this length right here? Half of the base. Do you see that? If this is my base length and this is going directly in the center, this would be half the base. Okay, so if this was 4, then we would use 2 in our Pythagorean theorem. It helps to really draw these pictures. Okay, so if we were to make a surface area formula, let's create one. Surface area of all of this. How would we create one? Okay, let's start with the base. Base times base, or base squared, right? Base times base plus, did you want to use x, or is b okay? Okay, we're just making up our own. Okay, and then how many triangular faces are going to be the same? All 4, so 4 times 1/2 base times, what's the height of our triangle? Is it h or s for the triangles? S. Okay, the slant height is the height of the triangle. Right? When we open it up, the slant height is actually the height of the triangle. The height is for volume, so that's this height is not going to be the same as this, the height of the triangle. Are we okay? Yeah, Zach? Yes. You can. So then you could actually simplify this to be 2bs. It's funny that I chose those letters. Okay, that is funny. So you can simplify this if you want. I'm going to leave it for now, but if you want, absolutely. Okay, so underneath, let's draw the rectangular. Let's see how good we are at drawing rectangular pyramids. This one's a lot more difficult. Okay, so draw a rectangle base. Make it like a parallelogram. It's so funny. Oh, don't worry. It takes practice. Okay, now, you want to be very careful with this drawing, because if the clearer it is, the easier it is to understand. Mine's not the greatest, but it's... Okay, so here's my height. Now, will the slant heights be the same for the front and the side? No, they're not going to be. Because if this is L and this is W, right, Pythagoras Theorem is going to give different slant heights. So we have 2 different slant heights. Now on your formula sheet, let's draw it just like your formula sheet. Quinn, you with us? Can you poke him? Quinn, you need to stay with us. No, you're not. Okay, so we have 2 slant heights. Let's draw it just like your formula sheet so we can be consistent. So this is on your formula sheet. We have length, width, so we'll use the side one as S and the front one as A. Those are 2 different slant heights. So this is S. Okay, that triangle. And this one's A. So 2 different right triangles. Kind of hard to see. So if we were to draw these triangles, so they're a little bit easier to understand. We have this triangle right here. What would be this bottom length here? Half of the width, then we have our height, and then we have A. It'd be half of the width, because this goes over to here. And then this triangle with S is a little bit easier to see. So what would this length be here? Half of the length. We still have our height, H, and now our slant height, S. So,
why with the apostrophe? Why with the apostrophe?
Oh no, it's just how I draw my S's, so they don't look like 5s. Sorry.
Oh.
Just, yeah. Okay. So let's make the formula. So the formula, let's do first the base. How do we get the area of that base? I know. Length times width, okay, plus. Now, if we open up, we draw this net of this shape. Length, width, and you have your triangles like this. Okay, I'll just draw, well, I guess I'll draw this thing. It's not to scale. Please forgive my drawings. Okay, so notice S, slant height was here, and this is A. That's our net when it's opened up. So these two triangles are the same. So 2 of them times, it's a long lesson, I know. Get out of the way and the rest are easier. So there's 2 of these triangles. How do we get the area of each of these triangles? What would be the area of this triangle? A times L divided by 2. Good. Okay, these 2 triangles would be, because they're the same, so how to get the triangle of this area? S times W divided by 2. Now, could we simplify these formulas? Yeah, how could you, Zach? Yeah. So that's how they get the formula LW plus AL plus SW. Okay, on your formula sheet. So you should probably have that somewhere. Oh, we didn't even get we haven't even done an example yet. Isn't that crazy? Okay, here's my pyramid. Okay, so you can see the height of this shape is not the same as the slant height. Let's get to an example now. Are we kind of understanding the formulas? Where they come from? Sort of. This one is tough, right? This is like the Mac Daddy of the unit. It's tough as it gets, I promise you. Okay? So let's start with a square pyramid. Can we do number 3? What? We will. We're not just going to do number 1. We're going to go through this. Okay, so number 1. Now, draw a net to calculate the square. So one way we can solve these is draw a net. So if I were to draw a net of this shape, okay, do we know the length and width of this shape? What is it? 8. It's a square. Why does that make me very happy? Okay, why is it easier? All the triangular faces will be the same. Ignore my drawing. Of course, it doesn't look that way. Okay, do we know the height of our triangle? Of all our triangles? Yeah, they give us the slant height. So this one, easy peasy. Okay, so formula. So our formula for our shape here, we're going to go the area of the base, which is a square. So we can go, if you want, we can leave it as length times width or base squared. Yeah, okay. Plus, we have 4 triangles. It's going to be 1/2. Do you want to just do BH? BS maybe? Because it's a slant height. I know, sorry. Brady Shaw. Okay, so because this is our slant height, right? It's just different than H, our vertical height of the shape. Okay, so let's fill it in. B is our base. 8 squared plus 4 times 1/2. Now, if you want, we can just simplify this to a 2, or you can leave it. Doesn't matter. Our base is 8 times our slant of 10. Can we type this into our calculator? Just like that. Yeah. Times. Okay, so 8 squared plus 4 times 1 over 2 times 8 times 10. You could also just use time symbol instead of bracket. When you're getting this down, you should be writing your notes down. One divided by 2, just 1 divided by 2. 224. Now what's the units going to be? Centimeters squared. Okay, so your unit exam, this would be out of 3 marks. Okay, so you're going to get a mark for your formula, a mark for substitution, and a mark for your answer. Yeah, a mark for your formula. So it's showing your work. Okay, that's how this would be out of 3 marks. Okay? Yeah, but you still have to show this work. Yeah, this question. This question's easy. All right. Did everyone get this down? We move on to the next one. How you doing? Do you need to stand up and take a break? Yeah, go get a drink. We'll take 30 seconds to a minute. A right rectangular period has a base dimensions of 4 by 6. Let's draw this to the best of our ability. Okay, 4 by 6. I'm going to put the length in the front always so that I can match it with the formula on the formula sheet. And then the width on, so 4 and 6 meters. Okay. Something like that, ish. Okay. And a height of 8 meters. So this is probably the toughest it gets. So they give us a vertical height of 8 meters. Yes, Nadia. So it's always helpful to draw the net, and this would not be the slant height. So if we were to draw the net of this shape and we were to open it up, we would actually have to figure out, 4. We'd have to figure out what the slant heights are. We're going to have to solve for them. So the 8 is the vertical height of the shape, but that's not our slant heights. We have 2 slant heights. We have one here. Yeah, this would be this red line would be right there. You're going to use 8 in Pythagoras Theorem to get your slant height. So it's neither of the slant heights. So there's this one. We're going to always call this guy S. Sorry, Nadia. I'm just going to draw this first really quickly. Oops, not purple. So this one here is A. So they're not, 8 and A are not the same. So it's not going to show up in our net. No, not at all. The reason why, because that's our vertical. No, it's nowhere, actually. Let's use, it's not even there, okay? It's not even in our net. So in our net, we have our A, which is here, and we have S, which is red. Okay, so we need to find both our slant heights. I love how, yeah, that's beautiful. It's not. I'm being sarcastic, sorry. Okay, so what you would want to do from this is draw your 2 right triangles. So, because in order to find this surface area, we need to figure out A and S first, our 2 slant heights. Okay, because those slant heights are actually the heights of the triangles. So we have 2 right triangles. There's one right there, and there's one on the side. It's kind of hard to see that one. So it's really helpful if you draw them separately. So there's the one with S, and the one with A. Okay, so both of these, the vertical height would be what? Of the right triangles?
8.
8. Okay. Now with the S, what's this base length going to be? 3, half of our length. So this one's 3. And this triangle here, which is kind of hard to see, what's this base? 2. 2, 3. Okay. So now we can go ahead and find our slant heights before we can find our surface area. This is as tough as it gets. Does it make sense though? I was actually like losing sleep last night because I'm like, this lesson always, it's like you have to be able to visualize what's going on, and if your drawings are kind of ugly. Okay, so let's find S. So S squared is going to equal to 8 squared plus 3 squared. How can we type this in all at once? Yeah, square root both sides. So S will be 8.5. Was it bang on? Okay. Oops. So square root is second of the x squared. 8 squared plus 3 squared. Let's try and keep, let's go to 3 decimal places. This way we know our answer will be safe, or we won't mess up on the rounding in the end. So 8.544 meters. Yeah. Okay, and let's do A. So A squared equals 8 squared plus 2 squared, or square root both sides. So second x squared. Oh, you know what you could do to save time? If you push second enter, it'll bring back what you last typed in, and then you can go over and just change this to a 2. So 3 decimal places, 8.246. Okay, so now can we find our surface area? Yes. Okay. Now, do you want to use the formula that's on the formula sheet? The simplified one, the one on the formula sheet is the simplified one. So if you look at your formula sheet, it's this guy. Oh, it's not. Let's use the simplified one. Just cancel those out. Okay? So we just need to know the L and then W, right? A, S. So this is L, W, S, A, and S. There you go. So surface area will be length times width plus A times L plus S times W. And if you want, you could, if you want to just find the area of the square, find the area of these two separately, and then these two, and then add them together, you'll get the same answer. You don't have to use this formula sheet. You can find them all individually and add them up. And that's okay. Okay, so what's my length? 6 times 4 plus A is 6 times L. 6. It's really important that, right, A and L go together. A times this is L plus S 8.544 times 4. Once you understand the formula, then it's easier to, right, because this is really, there's 2 triangles here, and the 1/2 and the 2 canceled out. So 6 times 4 plus 8.246 times 6 plus 8.544 times 4. Okay, did you get the same thing? 107 point. Let's go to the 1 decimal place. Uh-oh. Okay. So that would be centimeters square meter. Oh, good. Meters squared. Okay. Now, you could have also just figured out each one. Now that you know S and A, 6 times A divided by 2, and 2 of them, plus the rectangle, plus the area of these two triangles. Okay? That's fair too. You don't have to use this formula. Alrighty. How are we doing? Okay? We can skip. Well, yeah, let's see if we have time for 3 later. Let's start at 4 right now. The lateral surface area, keyword lateral. What does lateral mean? All faces but the base. Everything but the base of a square pyramid is 3,000 inches squared. So this lateral area, really this lateral area is what shapes? What's included in that lateral area? What shapes? The 4, and are these triangles the same or different? If it's a square pyramid, they're all the same. They're all the same. So if our surface area, which is lateral, our lateral surface area, I'll put a little L. Yeah, sorry. It is a pretty ugly square. It's not even a square. It's really 4 times the area of a triangle. Would you agree with that? The lateral surface area is equal to 4 times the area of each triangle. Okay. So then, let's go on. The side length of the base is 50 inches. Okay, inches. Determine the height of the model to the nearest tenth of an inch. So it specifically says just height, so we're looking for that. Vertical heights, not the slant height. If they want slant height, they'll say slant height. Okay. Okay, you'll need slant height to get the height. Absolutely. Okay, so here's slant height. Well, remember, it's the lateral height, so this wasn't included. This base wasn't, it's just the 4 triangles. So could we get the area of one of the triangles? It would be 750, 3,000 inches divided by, inches squared divided by 4. Because this area is just the 4 triangles. So 750 inches squared. Okay? So in our Pythagoras theorem, do we know this base length here? Yeah, what would it be? It would be 25, half of the 50. Yeah. Okay, so if we knew slant height, then do we have enough information to get height? Yeah, so we now know, if we were to draw the net, we know the area of one of the triangles is 750. Do we have enough information to find the slant height? Yes. What's the formula for area of a triangle? Base times, in this triangle, what's our height? What letter? S. Divide by 2. Okay. So let's fill in what we know. Do we know the area of a triangle? Yeah, 750. Do we know the base? Yeah, it's 50 times S divided by 2. How can we simplify this? Can we figure out 50 divided by 2? 25. Yeah, it's 25S. Now what, to get S by itself? Divide by 25. And I'm pretty sure it's going to give us 30. Okay, does that give us the height of our shape, though? Just the slant height. So how do we, if we know slant height is the, what do we call that in this triangle? The hypotenuse. So to get our height squared, so the 30 squared minus 25, we have to use subtraction because we know the hypotenuse. Questions? Does that make sense? Because we want s by itself. We were solving for slant height. Yeah. So this way it gave us s by itself. Okay, and square root both sides. So type that into your calculator and we get our final answer. What do we have to round to? 30 squared. Did it say rounding? Nearest tenth? What is that? 16.6 unit inches. Don't forget your unit. Okay, how do you feel? Bad? Should we look at number 3? Let's do it quickly. It could show up on your homework, yeah? Okay. 3 was on the same page, right? Right here. We can go through this one pretty quickly. We have a right cone. How about you try it? Did you want to try this one? Okay. Okay. So they tell us that the radius is 4 meters and its height is 10. The formula is there for you. It says calculate the surface area. Pi r s plus pi r squared. So looking at our formula, do you know everything in this formula here? You do. Okay, do they give you do you know what pi is? Yeah, and in our calculators, we're actually going to use the symbol pi, not 3.14, and I'll show you how to do that. Do we know the radius? Yes. Do we know the slant height? No. That slant height's right here. We know height, not slant height. So how do we get slant height? Slant height squared is 10 squared plus 4 squared. And then square root both sides. So our slant height is square root button is second square root. 10 squared. Okay, and we're going to try and use our exact value if we can. So I'm going to write down 10.77. Is everything okay? What's so funny? Did I miss it? Huh? Okay. Okay, so 10.77. So now do we have enough information? Yeah, so pi, you leave it as pi, times 4. I'll show you in a second. Times 10.77 plus pi times 4 squared. So the pi button is right where that hat is, right here. Okay, so you have to push second. So second hat, I guess. It's a hat.
It's called hat, right?
Or correct. In math, we call it a hat. Times 4 times. Now, instead of typing 10.77, what can I do to keep my answers perfect? Second negative, yeah. Second negative will give you previous answer. Oh, there you go. Plus pi, second hat, times 4, and then the squared button's right there, 4 squared. Okay, 185 to the nearest square meter, 186. do you feel? Okay? You can do this? If I told you this is probably the hardest part of the unit, you feel okay? You can overcome this. I believe you. Right. So,